After light has passed through the cornea and pupil, the light passes through the lens. It passes through the lens. It's kind of like a camera lens. The lens focuses light onto the back of the eye, where seeing really starts to happen. The eye can see stuff from a far distance and a short distance, just like a camera. The lens is held in place by a bunch of fibers, which are attached to the ciliary muscles. The ciliary muscles change the shape of the lens to let the eye change its focus from something close by to something far away. To see something near, the ciliary muscle makes the lens thicker. To see something far, the ciliary muscle makes the lens thinner. The retina is the back wall of the eyeball because the lens focuses light onto the retina. The retina has millions of light-sensitive cells called rods and cones. About 120 million rods and 7 million cones in each eye. The difference between them is between their visions. Rod vision is black and white, and cone vision is colorful. Rods help you see in the dark. Cones are sensitive to the colors red, green, or blue. Together, they let us see millions of colors, but cones need more light than rods work with. The optic nerve is a bouncy nerve behind the retina. The optic nerve carries messages to the brain about what you are seeing. The rods and cones change the colors and shapes you see into millions of nerve messages. Then the messages are carried along the optic nerve to the brain. It's like an eye sending a report on what you're seeing. Then the brain translates the report on the object you are seeing, and that's how we see.
Wow.
The ear has 3 parts: inner, middle, and outer ear. Pinna or auricle, that's the outer ear I meant. The pinna acts like a funnel, collecting sounds to channel them into the ear canal. The ear canal is also part of the pinna. The ear canal produces earwax, which has chemicals to fight off infections that could hurt the skin in the ear canal. The earwax also traps dirt to keep it clean. The eardrum is found in the middle ear. The eardrum is a very sensitive part of the ear. It is a thin piece of tightly stretched skin. The sound waves that the outer ear collected causes the eardrum to vibrate. When the eardrum vibrates, these 3 tiny bones on the other side, called the ossicles. The 3 ossicle bones are called the hammer, anvil, and stirrup. The ossicle bones are connected to the cochlea. The cochlea is a small, curled tube filled with liquid. The vibrations of the ossicles produce waves in the liquid inside the cochlea. The cochlea is lined with tiny little hairs. When the fluid in the cochlea moves, it moves the hairs, which send nerve signals to the brain, and the brain recognizes the sound, and that's how we hear. Volcanoes are formed when magma from within the upper mantle. Volcanoes are formed when magma from within the Earth's upper mantle works its way up to the surface. Molten or hot liquefied rock located deep below the Earth's surface is called magma. Magma is formed when temperatures within the Earth's crust or mantle are very hot, and when pressure in places within those layers decreases. At the surface, it erupts to form lava to form lava flows and ash deposits. Lava is molten rock generated by geothermal energy and expelled through fractures in planetary crust or in an eruption, usually at temperatures from 700 to 1,200 degrees Celsius. The structures resulting from after setting and cooling are also sometimes described as lava. Over time, as the volcano continues to erupt, it will get bigger and bigger.
Wow, very good. Very, very good. So you see how complicated it is. It all happened by accident. You believe that? No, it's nonsense. It can't be so precise and all this delicate things happening. And so you see the eye, the ear are very, very complicated instruments. And they're meant for accumulating knowledge or collecting knowledge. Okay, go ahead, Shrestha. We'll go through everyone will get a chance, I'm sure.
I did the eye, and then I did volcano.
Okay.
So the eye is like 6 main parts. They're the cornea, the iris, the pupil, which is like the front part of the eye, and the lens, the retina, and the optic nerve, which are all behind the part that we see. So the eye is a tough ball of tissue, and it sits in the eye socket. So the cornea, which is the first layer of the eye, is a transparent surface that protects the pupil. And the iris, which is underneath the cornea, it's the colorful thing in our eye, and it controls the amount of light passing into the pupil, so it works like a muscle. And the pupil is the opening in the lens that allows light to enter into our eye. So the lens helps light to get to the retina. The retina contains a layer of billions of light-sensitive cells, and these light-sensitive cells allow us to perceive the image that we're seeing. And then the optic nerve takes this image and it allows our brain to interpret it. So how we see light and dark. So we have 2 different types of light-sensitive cells, and they're called rod cells and cone cells. So cone cells are called cone cells because of their cone shape, and rod cells are called rod cells because of their rod shape. And cone cells respond to bright lights and different light wavelengths, so they enable us to see brightness and color. Rod cells, on the other hand, are only sensitive to dim lights. So at night, our rod cells are activated, but our cone cells are not activated, so it's really hard for us to see colors. But in broad daylight, our cone cells are activated, so that means that we see a lot of color. Now, how does our eye control the amount of light that passes through? Well, this is what the iris does. So at night, the pupil dilates, making the iris expand, making it easier for us to see. So when the iris expands, there's a bigger opening in our lens, making it easier for us to absorb more light. But in broad daylight, when there's too much light, the iris closes up so that the pupil doesn't get too much light. So as humans, we have something called stereo vision, which means that we have 2 eyes which give us 2 viewpoints to an object to judge the distance. So our right eye and our left eye view are combined to create a 3D image, which allows us to judge the distance. So if you look at your hand and you close one eye and then you close the other, you can see that there's a difference. And basically what you're doing is like you're finding like the average of the 2 images. If you were to only have one eye, you wouldn't be able to judge the depth. So certain people have conditions such as near and farsightedness. What does this mean? So the iris, which is the muscle, is not the only muscle in the eye. There are muscles behind the lens which change the shape of it in order to allow it to focus light on the retina. So when the eye is unable to do this, the person develops sight, near or farsightedness. Farsightedness is when the muscle isn't strong enough. When a person is farsighted, the light rays are focused behind the retina. This means it's hard for the person to see things up close. In order to correct farsightedness, one must wear convex lenses because the convex lenses concentrate the light rays so that their point of focus is not behind the retina. And nearsightedness is when the muscles cannot relax the lens enough. Light rays are focused before the retina in nearsightedness. This makes it hard for the person to see far away. To correct this condition, one should wear concave lenses. These lenses spread out the light rays. So that's how the eye works, and those are the different conditions that people have with the eye. And then a basic volcano, so there are three basic points for the volcano. So there's one, how the volcano basically erupts, and then there's an andesitic volcano and a basaltic volcano. So basically how a volcano erupts is when slabs of rocks forming the Earth's surface begin to move. And when plates collide, then they create very violent volcanoes, since the magma in the upper mantle of the Earth rises up to the surface. So it's the same thing as shaking and opening a can of soda. When you shake and open the can of soda, it erupts because of the pressure inside. So it's similar to that. So an andesitic volcano, they're named after the Andes where they were first found. So andesitic volcanoes are steep-sided cones, and they form as the melted plate erupts from the ground. The volcano builds up through the lava flow and ash layers from the explosion, so it slowly builds up through each explosion. When the pressure in the andesitic lava is released at the surface, it produces something called nube ardente. And nube ardente is like a glowing cloud which causes an avalanche. It contains gases, fragments of rock, and hot ash, which move at speeds of up to 60 miles per hour. So this is what happened with Mount Vesuvius in Pompeii, where the entire city was covered with this ash, and they were all killed. So that's the first type of volcano. And the second type of volcano is called the basaltic volcano. And basaltic volcanoes are formed because of hotspots. Hotspots are areas deep within the mantle, which are areas of heat and turbulence. They create the right environment for basaltic volcanoes. So the molten magma rises from the mantle. When it breaks through the surface, it forms a dark, runny lava called basalt, which runs for a long time before hardening. The result is a shield volcano, which is low and broad. Most of these volcanoes lie at the bottom of the ocean, and you can identify this volcano by the way it erupts. The molten basalt sprays into the air like a fountain. So these are normally found at the bottom of the ocean because it's hard for them to come all the way up to the surface of land.
Okay, very good. Thank you. All right, who's next? You want to go next? Go ahead. Yeah.
So I did all three of them. So the first ones I did was a volcano. So a volcano is a vent or chimney that connects magma from the inside of the Earth's crust to its surface. The liquid inside is called magma. When it comes out, it's called lava. How does it erupt? The molten rock starts stored in the magma chamber, rises through the crater pipe pockets, and travels up the main vent. Gases erupt. Gases expand and water becomes steam, creating pressure. When the pressure is too much for the volcano, then it erupts through the crater and secondary side vents. The volcanic gases include things like the water vapor, carbon dioxide, sulfur dioxide, hydrogen chloride, hydrogen fluoride, and hydrogen sulfide. Many say that, So the eye cornea is the dome of the clear tissue up in the front that focuses light as it passes through. The iris is the colorful part behind the cornea. The middle of the iris is called the pupil. The pupil is an opening that lets light in. The iris has muscles attached to it. The change in its size makes the pupil bigger or smaller to control how much light goes through. The pupil gets smaller when it's a lot of light and bigger when it's dark. Blinking protects and moistures the eyes. The lens focuses the light onto the back of the eyes where seeing starts. The lens is held in place by a bunch of filters that are attached to ciliary muscles. The ciliary muscles change the shape of the lens to let the eyes change its focus. The ciliary muscles are used to see something near and make the lens thicker. To see something far, the ciliary muscles make the lens thinner. The retina is the back wall of the eyeball. The lens focuses the light into the retina. It has millions of light-sensitive cells called rods and cones. There are about 120 million rods and 7 million cones in each eye. Rods can see black and white and shades of gray and helps us see the shape and form of things. Also helps in the dark. The cones are sensitive to 3 colors, red, blue, and green, and together we see all the other colors. The optic nerve carries messages to the brain about what you're seeing. The rods and the cones change colors and you see millions of nerves messages. They get carried to the brain using the optic nerve.
I did the eye, I didn't do the other two. Where is it? The question was, how does the eye work? The eye has lots of different parts to let you see. The window to the eye is the cornea. The cornea focuses light as it passes through. The cornea is a dome of clear tissue. The colorful part is called the iris. The iris is right behind the cornea. In the middle of the iris is a black circle called the pupil. The pupil lets light in the eye. The iris has muscles attached to it that change its size, making the pupil bigger and smaller to control how much light gets through. The pupil gets smaller when there is a lot of light and gets bigger when it's dimmer. After the light passes through the cornea and the pupil, the light passes through the lens. The lens passes the light to the back of the eye, where the seeing really starts to happen. The lens is held in place by a bunch of fibers which is attached to the ciliary muscle. The ciliary muscle changes the shape of the lens to let the eye change its focus from something close by to something far away. To see something near, the ciliary muscle makes the lens thicker. To see something far, the ciliary muscle makes the lens thinner. After the lens is the retina, the back of the eye. The lens focuses the light to the retina. The retina has a lot of light-sensitive cells, which are called rods and cones. There are about 120 million rods and 7 million cones in each eye. The rods help see black, white, and shades of gray, and shape and form of things. They also help see in the dark. Cones are sensitive to red, green, and blue. Together they help us see all the other colors. Cones need more light than rods to work. The active nerve sends what you saw to the brain and translates it, and that's how you see.
What were the 3 primary colors? Red, blue, and green, did you say?
Yeah.
Okay. Who's next? Okay, go ahead. You're next. All right. Agastya.
So I only did the eye.
You drew a picture of it? Also?
Yeah.
Very good.
So first, a light enters the eye through the cornea. Then the iris adjusts the size of the pupil to control the amount of light going in. So like if it's like a dim light, it'll make the pupil bigger, and if it's a high intensity light, the pupil will become smaller. And then the eye lens is held up by a thing called suspensory ligaments, and they work to see close-up objects and far-away objects like clearly. And that, so in the middle of the cornea and the eye lens, there's something called the aqueous humor, and it keeps the eye from like collapsing due to atmospheric pressure.
Whoa.
And then next, the
The
retina.
the eye can collapse then.
Yeah.
Okay.
Next, the retina helps to see the color and the intensity of light with rods and cones. Cones can mainly see red, blue, and green, and rods help see all the other colors. Then an inverted image is formed at the back of the retina. Then the optic nerve
Inverted
sends
image, right? Inverted image.
Yeah.
Yeah.
Then the optic nerve sends like electrical signals to the brain, which the brain converts into an image.
That's it?
Yeah.
Okay. Does it sound like it happened by accident?
No.
It's a crazy theory that it all happens by accident. This is very technical, very precise, very sophisticated. Go ahead.
I did the eyes and the ears. The eye
We
is a
should
very
do the nose also.
the eye is a very complicated system that can help you see. The window to your eyes is called the cornea. The cornea is a dome of clear tissue up in the front of your eyes that focuses light as could you not? That focuses light as it passes through. The iris is a colorful part of your eye behind the cornea. In the middle of the iris, there is a black circle called the pupil, an opening that lets light into the eye. The iris has muscle attached to it, which makes the pupil bigger or smaller to control the amount of light that gets in. The pupil gets smaller when there's a lot of light and bigger when the light is dimmer. Blinking protects and moistens the eye. After the light passes through the pupil, after the light passes through the pupil, it passes through the lens. The lens focuses the light onto the back of the eye, and this is when we actually start to see. The lens can focus on items that are close to the eye, and items that are farther away to the eye. The lens is held by a bunch of fibers that are attached to the ciliary muscles. Ciliary muscles change the shape of the lens to let the eye change the focus from something close to something far away. The light rays pass through a dense, transparent, gel-like substance called the vitreous that fills the globe of the eyeball and helps the eye hold its sphere-like shape. After the lens comes the retina, the back wall of the eyeball. The lens focuses the light onto the retina. The retina has millions of light-sensitive cells called rods and cones. There are about 120 million rods and 7 million cones in each eye. The difference between them is our rods can see black and white and shades of gray. They also help us see the shape and form of things. Rods also help us see in the dark. Cones are sensitive of one of three colors, red, green, or blue. Together, they help us see millions of colors. Behind the retina is the optic nerve. It carries messages to the brain about what you're seeing, and this is how your eyes work. I'm going to move on to the ears. There are three parts of the ear: the outer ear, the middle ear, and the inner ear. The outer ear, or a pinna, is like a tunnel collecting sounds into the ear, which is also. The outer ear is The outer ear, or the pinna, is like a tunnel collecting sounds into the ear canal, which is also part of the outer ear. The ear wax in the outer ear helps keep the skin clear and traps dirt and fights infection to keep the ear clean. The middle ear contains the eardrum, which is a very sensitive instrument. It is a thin piece of tightly stretched skin. When sound waves enter the ear canal, it vibrates the eardrum. When it vibrates, it moves 3 sets of bones on the other side called the ossicles. The 3 bones are called. The 3 bones are called the hammer, the anvil, and the stirrup. Then comes the cochlea, a small circle tube with liquid in it. The vibrations in the ossicles create waves in the liquid in the cochlea. This part of the ear is lined with tiny hair. When the liquid moves, it moves the hair, which creates nerve signals that are sent to the brain. The brain recognizes these sounds, and so you hear.
Very good. Okay, Augustia. Oh, you did it. Okay. Anybody else? Krishna? Okay, hold the mic closer to you.
The eye has like 6 things in it to make it work. The cornea focuses light as it comes through. The iris is behind the cornea, and it has muscles that make the pupil, which is inside the iris, bigger and smaller to open light for it. And then there's a lens, there's a retina, and then the optic nerve is the one that sends all the light to the brain, like picture of what you see to the brain. And then on the ears, there are 18,000 eardrums in our ears. Each eardrum is the tip of a pin. They hear sound by vibration levels. Like our vibration sound levels are like 80 to 90, whereas dogs have like 150 vibration levels.
They're superior to us.
Yeah.
That's one reason to want to be a dog in your next life. You have more eardrums. Advitya? No. Okay. Anybody else didn't get a chance to read? Read? Okay. All right. So that was an exercise so you understand how complicated the senses are, and it's a miracle of mechanical engineering. You know, I mean, if you look at it, it's much more amazing than anything anyone has done, and it's organic. It's not made of metal or iron. It's just made of skin and muscle, you see. So it's even more difficult. So usually we have all these complicated machines, but this is a human being acting like a robot, in a sense. Not a robot, but it's like you have this highly sophisticated machinery, and it helps you to acquire awareness of the world, and makes you conscious of your surroundings in the form of light or sound, etc. So we don't just have the eyes and ears. We have the eyes, ears, the nose, and the skin and the tongue. So we see all these senses are extremely complicated, and they're working together at the same time. So they're synchronized. So it's impossible that anything could have, that something like that, so precise, was developed by randomness, random trial and errors over billions of years. And there was a devotee named Sadapuda Das, who unfortunately died. But he was a mathematician, and he wrote a book. I have that book. Maybe I'll bring it and share it with you. He proves mathematically that it's impossible that such complicated systems, like we just read, like the eye, the ear, the nose, could be created randomly through trial and error only, and not intelligence driven. So the scientists are basically teaching a hoax, something that's not true. And what they're doing is not scientific. Now, see, they've analyzed eyes and ears and things like that, and broke it down into, simply give a description of what they have discovered with their observations and their microscopes and so and so. And they've done a lot of dissections of human beings to try and figure out how the eye works, how the tongue works, how the ears work, and so forth. But all they find is tremendous complexity and tremendous engineering that they themselves could never do. But although everything they do, they get recognition for it individually. Like if they did some important experiments and it pushed science forward, they'll get a Nobel Prize for and they'll win some money and they get recognition. So whatever they do is intelligence driven. But they say that these things that they study that are highly technical, they're not intelligence driven. It doesn't make sense. They're not rational. What they're seeing is much more complicated than anything they've ever built themselves. So they can build things with iron and plastic, but this machinery that's in the body is built with tissues and bone, right? So they're not capable of doing that. And look how complicated it is. There's how many rods for color? 120 million? How many rods for black and white? Huh? Cones. How many cones for black and white? Yeah, just see how complicated that is. Do you know you have 120 million color cones? And how many million? 7 million. You know what that is? Count it. 7 million or 120 million, and they're functioning. And it's right in here, and it's right there. Do you understand what we're talking about? This is unbelievable. And it's completely synchronized. The eyes, the ears, the brain, everything is working together. It's an unbelievable machine. And scientists are looking at it and they say it happened by accident. Does it make sense? No, it's crazy. So, on the one hand, they say nature is orderly, and on the other hand, they say it's happened randomly. The orderliness was produced randomly. So, we should not be fooled by them anymore. We should understand that there's a much greater scientist that's done all this, and he did it just with tissue, right? And living things, not dead things like metal. He did it with tissue, and the way Krishna did it is unimaginable. Okay, so this should help you understand more the 6 steps to convince an atheist that there is a superior intelligent person in the universe. So, your homework for Friday is to now now you can do this homework. Study the 6 assumptions of the scientists and show what part of those assumptions are true and what part are untrue. 6 assumptions of the scientists. Do you have a sheet of the 6 assumptions? No? I thought you gave to everybody. Okay, who said no? Raise your hand so we know who said no. Okay, so you go and see Ananda Prabhu. He's going to give you the 6 assumptions of the scientists. You have it? Are you going to use it for Friday? Okay, I hope so. So now you can go and you have a little bit more understanding how complex the human body is, and go one by one of those assumptions and show that it's impossible that assumption happened by accident. So some of their assumptions may have, part of it is true, like when they say nature acts orderly, that's true. But then the second one says, the third one says, there's no unnatural cause of the orderliness. That means there's no intelligent person behind it. But that's not true. You see? They say one thing that's true, and then they say something that's untrue that would make it that cannot produce something so complicated. You see? So you see which parts of the 6 assumptions are true and which parts are not true, and give some explanation why it's not true. Okay? Haribol. All glories to Srila Prabhupada ki jai. Also, we're going to begin to discuss the moon landing, because it was the 50th anniversary of it. And I'm sure everyone's making a big thing of it. And we're going to discuss how it probably didn't happen. Yeah, it probably didn't happen a lot. And even if it's true, they have nothing to show for it. Okay, so get the sheet. You don't have it. 6 assumptions.